Hey everybody, Miss Sawyer back with you. Literal equations and solving equations today. You've made it to this point, so hopefully you're finding this to go a little bit smoother this time around. Now today's going to be a little bit longer, so make sure you've got some time. Won't be more than about 15 minutes, but it might take us a few extra minutes to get this one done. So in here, guys, when we're talking about literal equations, okay, these right here, not 1, 2, 3, and 4 are literal equations only because they are simply equations with all variables. What they're trying to get you to do is solve for the indicated variable. They're asking for you to get everything away from that one letter. How you do that is going to take some practice getting used to. So if we take this expression here, we have u equals AK divided by V minus W. And our goal in this whole process is to get this one little a all by itself. So if I want to do that, I want to think about working as far away from A as I can to start off with. Well, the furthest thing away from A, truthfully speaking, is this denominator. Well, there's a really easy trick to get rid of this denominator. First things we want to do, put it in parentheses. We are going to multiply both sides of this equation because remember in algebra, what you do to one side of an equation, you must do to both. Well, if I multiply the right side by v minus w, the denominator will disappear. Well, that leaves me with this over here. So I'm going to rewrite the problem as u times parentheses v minus w equals a k. Well, a and k are right now being multiplied. So in order for me to get multiplication undone, I have to divide. If I divide by k, these k's will cancel, but whatever I do to one side of an equation, I must also do to the other. Here is everything away from a. So my final answer would be a equals u times v minus w all divided by k. So again, these take some practice and some getting used to, but they are completely doable problems. In problem 2, again, they're asking us to solve for A. So let's highlight where A is first so that we can see where it is. A is right in the middle up here up at the top. So the first thing I would look at doing again would be getting rid of what's furthest away from it, which is this divided by W. So if I have U equals VAK divided by W, the first thing I want to do is multiply both sides by W to get rid of that W. So now I have UW equals VAK. V times A times K. I need to get rid of V and K. So if they are being multiplied, we will just divide both sides by V and K. This gets rid of V, this gets rid of K. I'm left with just A on this side. So we have A equals UW divided by VK. And we are all done. So they're not the worst things in the world, but you have to get used to them. Now, in a problem like 3, I'm going to approach this a little bit differently because where we're trying to get to is I want to get this x down here all by itself. I'm actually going to make the suggestion that we cross multiply right through the middle. Well, if I multiply going down this direction, k times v would just be kv. If I multiply going this direction, I would get x, w, y. Well, now I don't have any fractions anymore, but x times w times y, I need to get rid of the w and the y to solve for x. So we will divide both sides by wy. Those will cancel each other out here, and we'll be left with x equals kv divided by wy. Not the worst things we've ever done. All right, now this one, again, they've done you a nice favor by putting the parentheses in here. But I'm going to rewrite this problem and give ourselves a little bit more room to work. So we have G equals X times the quantity of D minus R divided by c. Well, I'm trying to get x by itself, so I need to get rid of the c first. So let's multiply both sides by the c first. It'll cancel on the right. So now we have CG, or GC, it doesn't matter, equals x times d minus r. Well, these are technically being multiplied. So I can do the same trick that I've been doing in these previous problems and divide both sides by d minus r, and now all of this cancels out and I'm left with x by itself, so I get x equals CG divided by the quantity of d minus r, and I'm all done. So when we talk about solving literal equations, just remember you're trying to get that variable by itself, so think of undoing everything that is happening to it. The second part of what we needed to run through today is just going back through a few solving equations. I wanted to make sure I had given you guys enough examples where you felt comfortable with whatever types of problems I might throw your way. So I wanted to show you some little troubleshooting tips of how to work with a problem like number 5, because we've got two different fractions in here and I want to show you there's some little tricks you can use. So let's take this 1/2 and distribute this and see what that turns into. Well, half of 2 is 1, and 1/2 times x is just 1/2 x equals 23 over 18. Now, my suggestion at this point, because I can multiply 2 times something to get 18, but I'm going to go ahead and use a little trick that I like to do to get rid of all of my fractions. This is called clearing the fraction. I'm going to take the largest denominator in the whole problem, and I'm going to distribute 18 times everything in this problem, and you'll see really quickly what's going to happen. Well, 18 times 1 is 18. 18 times 1/2, or half of 18, is 9x. And if I do 18 times this fraction on the other side, 23 over 18, the 18s will actually cancel and just leave me with 23. That is a much easier problem to work with. All we have to do now, subtract 18 on both sides. So we end up with 9x equals 5, and we divide by 9. So my answer would be x equals 5/9. And again, I will say this to y'all, if you get a fraction in the original part of the problem, it's not unlikely that you will get a fraction out at the end of the problem. So just don't be super surprised if you see that. All right, let's take a look at number 6. By the way, y'all, we are going to skip number 8 because it is awfully close to what happens in problem 7, but I like problem 7 better. So we're going to skip problem 8 to keep this a short video. Number 6, we've got 8 plus 5 minus 6. Well, we've got like terms right here. So let's just simplify. 5 minus 6 would be -1 equals -17. I want to then add 1 to both sides to get 8n equals -16. Divide both sides by 8, and we get n equals -2. In problem 7, we've got to do some distributing in here. So let's change colors so we don't run into our old work. So we'll leave the -5 alone, but we're going to distribute this -6 into this parenthesis set here. So we'll leave the -5. -6 times -1 is +6. -6 times times 3n is -18n equals -143. If we then combine like terms here, -5 plus 6 is 1, minus 18n equals -143. Subtract the 1 on both sides. So we get -18n equals -144. If we then divide both sides by -18, we will end up that n is going to equal a +8, because negative divided by negative will give me positive. For those that decided to try problem number 8, it is the exact same answer for V. So I just thought we would save our time today and not worry about that problem. So the last one we need to do is the one with variables on both sides. I'm going to rewrite it a little lower so we have some room to work. So we got negative 34 plus 5a. So let's go ahead and distribute the 4. And my apologies, y'all, if you heard the puppy in the background. So 4 times 1 is 4. 4 times 6a is going to be 24a. And then bring down your negative 34 plus 5a. Now you've got variables on both sides. Like I said to y'all before, my trick would be to subtract the smaller a or the smaller variable. So if we subtract 5a from both sides, we get 4 plus 19a equals negative 34. Subtract the 4 from both sides. That'll leave us with 19a equals negative 38. If we divide both sides by 19, we get a equals a negative 2. All right, so hopefully that gives you enough to get through your section on literal equations and solving equations. You are going to have 10 problems on your assignment today, but you do have some multiple choice in there to help you out. Good luck, and let me know if you have any questions.